Hello, today we're going to talk about scatter plots and association. Sometimes you'll hear me say correlation. It's another word that is used in the same manner, and it's talking about how we view the scatter plots. When we make a scatter plot, what we're doing is we are taking bivariate data, which involves two variables. And when I'm talking about bivariate data, I'm talking about like if I had the number of miles I traveled and the amount of fuel that I used, or maybe the number of people who attended a dance and the cost of the tickets, things like that. So there are two things that are being compared. They have a connection, they have a relationship, and the scatter plot is a graph on which we put that data, and it's plotted to show the relationship between the two sets of data. So our example here is a final question on a math test reads, how many hours did you spend studying for this test? The teacher records the number of hours each student studied and the grade the student received on that test. And so she took that information and she has put it in this, this table here. So think about when you study for a test. The longer you study, what happens with your grade? Does it increase or does it decrease? Well, typically, the more you study, the better you do on a test. And so you would expect that the information or the percentage on your test score would increase with the number of hours that you study. And so we're going to take this information and we're going to put it in a graph, and then we're going to kind of test that theory. So we're going to make the scatter plot, graphing the hours spent studying as the independent variable and the test grades as a dependent. And remember, independent is your x values and your dependent are your y values. Okay. So first ones I have is 0.75. So at 0.75. And then I had, at 1/2, I had 80. And then at 1, I had 80. At 1 hour, I had 85. 1.5 hours, I had 85. At 1.5 hours, I also had a 95. 2 hours at 90. 3 hours at 100. And at 4 hours, I had a 90. So does our graph show that the longer we study, that our grades would increase? So if we take a look here, when I didn't study at all, the scores was low. But as each student was studying longer, the scores were higher, weren't they? But the only one that kind of seems out of place will be this one right here, and we call those outliers. And we're going to talk more about outliers later. If I look at this, it's going up. As this is increasing, this is increasing. Okay? We're going to use the knowledge of linear equations to kind of help understand positive and negative associations. So remember from when we did linear equations and we graphed them, that if I had a line that was going down to the right, this was a negative slope. And so this would be negative. As we graphed our line and it was going up to the right, we said that these were positive. We're going to use the same knowledge to determine the association or how the sets of data are related. A positive association means that both data sets increase together. So as one is increasing, the other is increasing. So if my independent is increasing and my dependent is increasing, I'll get something that looks like this. And one way of looking at this is to draw a line through it. Does it look like it is going up to the right? And it very clearly does. So this is a positive association. A negative association means that as one set of data increases, the other decreases. So in this case, my independent variable is increasing, so it's getting higher, but my dependent is actually going lower. And so if I draw my line through these, it's a lot clearer to see that this is a negative association. It's going down to the right. Now, a no association means that there is no relationship between the two data sets. There's no positive trend. There's no negative. It's a possibility that if I draw my line this way, it does seem like they're going up, but there really isn't a good, strong enough feeling to be able to say that this is a definite positive. This is why it's no association. I could even draw a line straight across here, or I could draw a line up through here, and they don't seem to follow any type of pattern, do they? And so there's no association on that one. Data that shows a positive or a negative association and lie basically along a line, they exhibit a linear association. So when I take a look at this one and see how tight these points are with that line, this is an example of a linear association. It's very straight. The real line really close to that line. And then same thing here. For the most part, these line very close to the line. It's a negative linear association. But again, with this no association, there really is no specific way that shows that this is one is more right than the other. And so this would not be a linear. If I did this, I'd kind of swirly around like that. And that is definitely non-linear. Okay. So let's practice some. Says in our example 1 that Susan asked 20 people if they would buy a new product she developed at each of several prices. The scatter plot shows how many of the 20 said yes at a given price. Describe the association between the price and the number of buyers. So as the price increases, the number of buyers decrease. So see here, if it was $2, 20 people said yes. At $4, only 19 said yes. And at $6, 17. $8, it was 13. And so what's happening is as the price is increasing, fewer people are willing to pay that price. And so this is a definite negative association. If I tried to draw a line through it, you can see that it's really nonlinear because it has a curl to it. And so if I were to actually to follow those dots a little better, you can definitely see that it's got a curve to it, and so it's nonlinear. So this is an negative association that is nonlinear. Okay? So based on this information, if Susan increased the price to $14, what do you think would happen? And if you said it would be either one or no people that would buy it at $14, I believe you're correct. Because at $12, only 2 people were interested. Okay? All right, let's do the your turn. So it says that the plot shows the reading level and height for 16 students in a district. Describe the association and give a possible reason for it. And so they're comparing their height and their reading levels. And normally we wouldn't associate those two things because how tall you are doesn't describe how well you read. But when they did the test, they measured the students and then they had them take a reading test and measured their reading levels. What they found is that if you were shorter and you had a lower reading level, but as the reading level increased and your height also, for the most part, really did increase. And so the relationship is because of age. As you get older, you get taller, and as you get older, you have an increased reading ability. And so the relationship is actually tied into your age or your growth as you mature. And so we said that this is a positive. So it's a positive association. And if I were to draw a line through there, those would be pretty close. And I would say this is fairly linear. And I would say that is linear. And I would also say that as you age, you grow. and your reading improves, or your reading levels increase. Okay? So let's take a look at these. For 10 and 11, they want us to describe the set of real-world bivariate data that a given scatter plot could represent. And then we're going to define the variable represented on each axis. So when I'm taking a look at number 10, I see that it is a negative association. It's fairly linear, so that means that as my independent variable increases, my dependent variable decreases. And so we need to think about something that as this number gets bigger, this number will decrease. We could make this the number of miles traveled. And maybe this is the number of gallons of fuel. Remaining. Okay. So as we traveled, the longer we traveled, so we traveled 4 miles, and our number of gallons that we have left in the tank would be decreasing. And so for someone who traveled 1 hour or 1 mile, had a full tank. For someone who traveled 2 miles, well, it dropped to 8, had 8 gallons of fuel left in their tank and stuff, and so forth. So it doesn't matter what they are as long as it makes sense. Let's take a look at 11. And what do we know about this? Yeah, I would say this is no association. There's no positive, there's no negative. It's pretty much all over the board there. And so I need to come up with a scenario where the information would have nothing to do with each other. Okay, so let's think about, the number of people who like chocolate sundaes. How about that? So, so this could be, how about the age of students? And this could be number that ate chocolate sundaes. Okay. So the age of the students, does that have anything to do with if they like chocolate sundaes or not? No. Have nothing to do with each other. And that's a lot of times, that's when you'll see no association, because they really don't have any connection. Okay? If you have any questions about how to determine the association of a scatter plot, or to understand the different pieces of it, please make sure that you're talking to your teacher. Thank you.